So we have international opportunities just within the system. West Texas A&M, did you know that they were doing wind research for over 30 years? Where is it? It's up way up in the Panhandle or in the wind corridor. And I'm going to fly out there tomorrow to visit with them to talk about setting up a wind turbine up there. Corpus Christi, they're doing research in microalgae for biofuels. Well, so is Texas AgriLife Research, which I have highlighted in red. What the agencies can do for us, the agencies employ staff researchers who are interested in deploying fundamental research into practice. So remember the National Science Board report I just mentioned. There's an urgent call to action on how to take basic research into practice. The fact that the A&M system has these agencies will allow you as students working with your faculty advisors to actually take your work to practice. So that's an opportunity. And then we also have a health science center. Within the university itself, we have 10 colleges, and I highlighted in red the two main colleges working in energy, the A and the M. And so we have agriculture and engineering, and I'll talk about that partnership in just a minute. When EEI was formed last December, I immediately got phone calls from architecture. They're interested in energy efficient buildings, whether the new designs or how do you develop technologies where you can retrofit aged buildings and make them more efficient. So they're working with us. The Bush School is working with us and looking at energy policy questions. Geosciences is interested in wind energy for the atmospheric part. They can do wind calculations. They have lots of wind data over there. And they're also interested in offshore wind because the oceanographers have a lot of data about ocean currents that can help us as engineers design offshore turbines. Liberal arts is home to economics, and I'm working with a professor over there whose expertise, his PhD is from Berkeley, by the way, and looking at the economics of the electric grid and what happens when you integrate renewable sources of energy. And then the College of Science, well, we need chemists. I'm working with a statistics professor whose expertise is in short-term wind forecasting, and that's a rare expertise, as I found out. So the engineering program, okay, like I said, we have the state agency. So how can you as students make an impact in energy using the assets we have in the A&M system? So fundamental research is done in the Dwight Brooke College of Engineering. That's where you are, okay? And also in TEAS. We actually, this is an administrative bureaucratic complication, but the faculty actually do their research in TEAS. And again, you may be getting your funding for support from TEAS. The Texas Transportation Institute does research and deployment in all areas of transportation. It's land-based, water, air, pipelines, etc. I can go on and on. They're doing great work over there. And then TEAS. TEAS is our state agency that is home to our fire school, which attracts over 200,000 firefighters a year to get trained here at College Station. Law enforcement, and we're working together in looking at how we educate and train a workforce for different energy sectors. So it's a very valuable asset that we have. So in the system, we can go from fundamental research all the way to implementation. How many universities can do that? Not many. The same with agriculture. They're organized in a similar fashion, and I will talk about them in just a second in the context of bioenergy. Now back to BP. Like I said, I was pretty busy this summer with it, and with my system hat, I contacted all 11 universities, 7 state agencies, and the Health Science Center to see what expertise we had across the system that could contribute to capping the well or response. And actually, TEAS had to go out to Corpus Christi and train people who had never been in this business and teach them how to do basic environmental remediation efforts on the shores and deploy them out to the Gulf Coast so that they can help the communities along the coast. So they were very involved with training collection of expertise that can contribute and work with BP on the recovery issues, designing prevention programs, and that's a whole other talk in itself, and training. And so even the Health Science Center came on board, and in fact, I got another phone call just today at lunch, which is why I didn't eat. And there is a professor in the Health Science Center that has organized an energy sector emergency response program. What the BP oil spill revealed, it revealed a lot of things. One of them is that there is no test facility in existence that will test offshore sea bottom systems. And so all the infrastructure out there in the deep water has not been tested as subsystems or as a whole system. As you can imagine, the test facilities would have to be enormous in size. And so this oil spill revealed a lot of gaps in what we need to address. But one of them is human health. So they have organized and they are formalizing an energy sector component to the existing National Center for Emergency Medical Preparedness and Response. They are working with our engineering TEEX state agency. So we have a partnership with the Health Science Center, with TEEX, and with TEAS, and the College of Engineering. So that's pretty special right there. No one else in the country has this program. Now I want to zero in on the institute itself. It was born out of the College of Engineering. So I'm going to talk about now how the engineering departments are working in this energy space. You may or may not know, but we have 12 departments in the College of Engineering and with almost 11,000 students. You know we're big, you can tell in between classes. The second one on the left, the Biological and Agricultural Engineering Department, is actually joint with the College of Agriculture and Life Sciences. Okay. Now, let's talk about wind. Does wind fit into a department? How many say yes? How many say no? Most of you are not sure, and I'll tell you that in a minute. The BP explosion, was that a petroleum engineering problem?
It sure was.
You actually have a lot of mechanical engineers involved, electrical engineers, safety engineers. It wasn't just a petroleum engineering problem. Maybe they caused the problem, but everybody else had to fix it, right? Okay, so think about this. You're going to get your PhD, or maybe you're going to do a master's thesis in mechanical engineering. But if you do it in an area that's related at all to energy, I bet you $1, maybe more, a month paycheck. No, I won't go that far, but that you'll have somebody from outside of the department on your committee. Energy is not departmentalized in this manner. And so there's the question, how do we prepare our undergraduate and graduate students for careers in any energy sector? Now, I'm not going to tell you how old I am, and we can do a lottery and guess, but the fact of the matter is today, people change jobs often. And you may think you're going to go out in the world and be a mechanical engineer. I graduated with an electrical engineering degree, and I actually worked in industry for 5.5 years between my master's and PhD degrees. All 5.5 years I did mechanical engineering, not electrical. But the math was the same. And I could teach myself what I needed to do. So just remember, you're not going to be in the same job for life. That is rare. And so think about energy, but not in the context of departments. However, we need this expertise to work together. And that's always tricky in universities. Font size is small. Look at the bullet captions. So what I did about 6 years ago was take our expertise, not from departments, but in energy as a whole, and categorize our expertise in terms of feedstock and sources of energy and energy conversion technologies. And I did it for renewable and non-renewable.